Space is silent. It has no air, no wind, no sound. But it is not empty. Beyond the soft blue halo of Earth's atmosphere lies a realm filled with invisible fire, a ceaseless storm of radiation that drifts between the stars, carried by light, by particles, by the fury of dying suns. To the human eye, it is unseen. To the human body, it is lethal. Every astronaut who ventures beyond the safety of Earth's magnetic field steps into this storm, a storm that can slice through cells, alter DNA, and slowly unravel the body from within. Radiation is space's quietest killer. It does not roar. It does not burn. It simply passes through, leaving damage behind that no one can see until it's too late. And as humanity prepares to journey deeper, to the moon, to Mars, and beyond, understanding radiation is not just science. It is survival. On Earth, we live under protection we rarely even think about. The planet's magnetic field, generated by molten iron deep within its core, extends far into space, forming an invisible cocoon known as the magnetosphere. This shield deflects most of the high-energy particles hurled toward us by the sun and from distant cosmic sources. The atmosphere adds another layer of defense, absorbing dangerous radiation before it ever reaches the ground. It's why life can thrive here, why we can stand under the open sky without fear of being slowly erased by the universe's own energy. But step beyond that shield, even by a few hundred kilometers, and the story changes. Astronauts orbiting in low Earth orbit, aboard the International Space Station, still enjoy partial protection from Earth's magnetosphere. Yet even there, radiation levels are hundreds of times higher than what we experience on the surface. And once you leave orbit entirely, heading for the moon, or drifting in the vast gulf between planets, you are exposed to the full force of cosmic radiation. No shield, no atmosphere, only you, your spacecraft, and the storm. Radiation in space comes in many forms, each with its own danger. The first comes from our own star, solar radiation. The sun constantly emits a stream of charged particles called the solar wind. Most days, it flows gently, a cosmic breeze. But sometimes, when the sun erupts in violent outbursts called solar flares or coronal mass ejections, it unleashes waves of high-energy protons that can flood space in minutes. These are known as solar particle events, and for astronauts caught unprotected between worlds, they are deadly. A single large event could deliver a dose of radiation strong enough to cause acute sickness, even death, in a matter of hours. Then there's the deeper, older radiation, galactic cosmic rays. These are particles born from the deaths of stars, accelerated to nearly the speed of light by supernova explosions and black hole jets. They travel across galaxies, through magnetic fields, through everything. They can penetrate metal, electronics, and flesh. They are the whispers of ancient cataclysms still echoing through space. And for astronauts, they are an ever-present, unavoidable hazard. Even the walls of a spacecraft can only slow them down, not stop them. And when these high-energy particles strike human tissue, they break atoms apart, creating a cascade of damage deep within the body's cells. Radiation is not like a visible wound. It leaves no scar you can see, but its effects are profound and far-reaching. When high-energy particles collide with living cells, they tear through DNA, shattering genetic code. Sometimes the body repairs the damage. Other times, the repair is flawed. Mutations begin to accumulate. Over time, this leads to a host of dangers: increased cancer risk, cardiovascular disease, and neurological decline. The very structure of cells, their ability to divide, to heal, to function, begins to falter. In deep space, this happens silently. There is no pain, no sensation, just invisible destruction, molecule by molecule. Eyes can develop cataracts from radiation exposure. The central nervous system can be altered, leading to potential cognitive and behavioral changes. The immune system weakens, leaving the body vulnerable. And for astronauts on long-duration missions, like those planned for Mars, the risk compounds every day they spend away from Earth. Even the heart, that steadfast engine of life, may be scarred by cosmic radiation, as if slowly etched by the hand of the universe itself. We've been here before, briefly. Between 1968 and 1972, 24 astronauts left Earth's orbit during the Apollo missions. They traveled through the Van Allen radiation belts, into deep space, and to the moon itself. When they returned, something remarkable was discovered. Many of them later developed signs of cardiovascular disease far earlier than expected. Their lifetime exposure, though short, hinted at the long-term cost of deep space travel. And yet, they were lucky. No major solar flares struck during their missions. Had one erupted while they were on the moon, there might have been no way to protect them. The Apollo astronauts became both pioneers and living experiments, the first humans to feel, however lightly, the raw touch of the universe beyond Earth's shield. Their courage opened the door to the cosmos. Their experiences taught us that if we are to walk among the stars again, we must learn how to endure the invisible fire. Modern science is now racing to solve a problem as old as the stars themselves: how to live in a universe that was never meant for us. Space agencies around the world are developing new ways to shield astronauts from radiation. Spacecraft designs now incorporate layers of hydrogen-rich materials, plastics, and water, substances that can absorb or deflect charged particles better than metal. Inside future Mars-bound ships, storm shelters, small, heavily protected compartments, will offer refuge during solar events. Some researchers are experimenting with magnetic shielding, creating artificial magnetospheres to mimic Earth's natural defense. Others are studying biological solutions, ways to enhance the body's own DNA repair mechanisms, or even use pharmaceuticals to block radiation's effects on cells. Every idea is a step toward survival. Every innovation is a lifeline for the explorers who will one day drift far from home, surrounded by nothing but darkness and radiation and hope. In the end, radiation is not just a scientific problem. It is a test of human resolve. We have always been fragile creatures living in a dangerous universe. We have faced volcanoes, ice ages, meteors, and pandemics, and every time, we found a way to endure. Now, as we stand on the edge of interplanetary exploration, we face our most invisible enemy yet. And still, we go forward. Because the desire to explore, to see what lies beyond, burns brighter than fear. The cosmos is not safe. It never has been. But within that danger lies discovery, and within discovery, purpose. To journey into deep space is to risk everything for the promise of understanding. It is to accept that we may not yet have all the answers, but that we will keep searching until we do. When astronauts gaze out from their spacecraft windows, they see beauty that no human eyes were meant to see. The glow of distant stars, the curve of alien worlds, the faint blue shimmer of Earth far behind them. But beyond that beauty is a silent storm, a storm that tests the limits of the human body and spirit. Radiation reminds us that space is not a gentle place. It is ancient, raw, and filled with forces that care nothing for survival. Yet, somehow, that makes our presence there all the more meaningful. Because every human who dares to cross that threshold, every explorer who braves the unseen fire, carries with them a piece of all of us. They are the living proof that life, fragile as it is, can reach beyond the limits set by nature itself. The radiation may scar, It may threaten, it may try to erase, but still, humanity moves forward. Because in the end, we are creatures of light, and even in the heart of the universe's most dangerous storm, we shine.